everyone, and welcome to Nicola Wealth Real Estate's webcast. I'm Josh Anderson, Vice President of Development at Nicola Wealth Real Estate, and I'll be moderating today's conversation about building net zero. First, a bit of background. As part of our real estate portfolio, we own and operate advanced self-storage, with 8 facilities operating in the Lower Mainland and Vancouver Island. We're just underway with construction of the final phase of our Maple Meadows facility, and I'm excited to announce that this will be Canada's first certified net zero self-storage building. Here with me today are our 2 team members managing this project, Development Manager Nathan Ma and Construction Project Manager Jared Nicola. Nathan, why don't you tell us a little bit about the project?
Thanks, Josh, and thanks for having me on today. The project in question is called Maple Meadows Phase 4. The project's located in Maple Ridge, and to your point, it's the 4th and final building within this development. The project's 80,000 square feet with approximately 630 lockers. Upon completion, this facility will have over 1,400 lockers and be the largest facility within our portfolio and one of the largest facilities within the Lower Mainland. The project started construction this past June and will be complete by summer of next year. One thing we're very excited to announce is we designed this building to be net zero. In fact, Canada's first net zero self-storage building under the Canadian Green Building Council's Zero Carbon Building Design Standard.
Well, that's very exciting. Jared, maybe I'll ask you the big question then. What is net zero?
Well, Josh, there's a bunch of buzzwords going around, but this all relates back to climate change. Simply put, net zero is defined as offsetting a building's greenhouse gas emissions through energy reduction methods, on-site energy production, and credits applied to carbon recapture projects. But in terms of connecting net zero to buildings, there's 2 key classifications of net zero. The first is net zero energy, which means the on-site generation offsets the building's total energy usage. And the second classification, which goes a step beyond net zero energy, is net zero carbon. Net zero carbon accounts for something called embodied carbon. Now, the term embodied carbon accounts for the full life cycle of all carbon associated with procurement, manufacturing, and eventual disposal of each component of the building. So for example, the steel of a building, it has to be mined, it has to be refined, it has to be brought to site, and eventually at the end of its life cycle, it has to be recycled and disposed of. So embodied carbon accounts for all carbon associated with that entire life cycle. Now, if you're going for net zero carbon, this is offset through carbon credits that are applied to various carbon recapture projects.
Thanks, Jared. Nathan, maybe you can explain why this project is a good candidate for going net zero.
As we started designing our Maple Meadows facility, we began to understand the characteristics of these self-storage buildings made them actually perfect candidates for net zero. When I say building characteristics, what do I mean by this? Is how the building generally operates. For example, these buildings have very low energy usage. Comparing this building to an industrial or manufacturing facility that has heavy equipment running 12, 14 hours a day, in our buildings, goods are just being stored. Another example is we have low occupant loads, and by this, I mean we only have a handful of people inside these facilities at one time. Again, a lot different than office buildings that have hundreds and hundreds of people coming in and out every day. And lastly, these buildings are essentially a giant box with no windows. Unlike a residential tower where there's a high percentage of glazing, the external temperature of the air and the sun can have a dramatic effect to the temperature inside. I want to go back to what you said earlier, Josh, about having our own operations team in-house. Having this vertical integration from development to operations really allowed Jared and I to be in a unique situation where we could leverage the knowledge and the resources from our operations team to really understand how these buildings live and breathe. This put us in a position where we can make calculated and sustainable decisions to make this building net zero.
Jared, taking a step back, can you walk me through at a technical level what some of the most critical elements of designing a net zero building are?
Well, Josh, as you mentioned, it is a very technical process. I'll try to break it down as simply as I can. The first step in any construction process is to come up with a baseline design. So we'll bring in a design team and they will detail every component of the building from the walls to the windows, the mechanical systems, the electrical systems. We'll then take that baseline design and those details and we'll apply them to a 3D model in a computer program that applies a historical weather model against it. Now, what that is taking the historical weather pattern for a specific place and applying it to the building to see how the energy usage in that building is going to be affected. Obviously, a building that we build in Arizona is going to have a different weather model than one we build in Vancouver. We can then use this data to see what areas of the building are causing the highest energy usages and what areas are the best to focus in on improving. Typically, we'll focus on mechanical systems, electrical systems, the building's operations, and the building envelope, which is the skin of the building or the roof and the wall assemblies.
So how do you determine if the changes to these systems are going to be cost effective?
So that process involves usually our general contractor and sub trades that we have on board early in the design process to get their input. So once we have the data and we know where we'll see the biggest savings in terms of operational costs, we'll ask for them to price each component, and then we can weigh the cost of adding that component or that change in design to the building versus what we're going to see in operational savings each year. And then the final stage of that process is once we've selected which upgrades are most cost effective, it goes back to the design team and they will redesign the building around those changes and issue construction drawings.
So given the importance of the energy model, what did you learn from it and what does it tell us about the project in Maple Meadows?
This was an interesting process for us. Our assumption based on the type of building it is with all these exterior doors and the concrete design of the building was that focusing on the building envelope was going to be the best use of our money, but we actually found very minimal improvement when we changed anything to do with the building envelope. What we did find was that focusing on the operational habits of the building, the mechanical systems, and then the final piece was the on-site energy generation was the most effective solutions for our value for money. We spent a lot of time with the operations team to understand how the building operates, the hours of operation, when the peak demands were, when the peak usage was, to tweak different parts of the building like the temperature settings or the lighting settings. The biggest shock to us actually was the upgrade to the mechanical systems showed a 68% reduction in energy usage. And as I mentioned before, we only saw 2 to 3% on any of the building envelope changes. This was mainly accomplished through switching away from natural gas as the heating source and adding things like an air source heat pump and lowering the fresh air that's coming in the building. From there, we tweaked, as I said, a lot of the building operation set points. So lighting levels, temperature settings, how long the lights stay on and what hours they're running at. And another interesting point on this was that just changing those settings, adding nothing else to the building's design, saw a 28% reduction in the overall energy usage. And the final piece after we combined those changes was that we added a solar array to the roof for on-site energy generation. And in that setup, we will use that in the winter for our energy generation, and we will feed back into the grid during the summer. The last piece of the puzzle is the step that we won't get to do until the building is complete, which is sub-metering. And the reason that's important is we have to test each component of the building to see, is it going to work as the model predicted it would? Now, we've built ourselves a buffer in several of the building systems so that we can still tweak how the building operates to bridge that gap if we need to, but our hope is that the design will hold true. Now, it might seem like we're giving away the recipe for net zero buildings going forward, but every building's geometry is unique. They're all different in terms of the height, the dimensions, the floor plate, and how the building is used. This is an extremely iterative process that required a lot of outside the box ideas to get to the final goal line.
Nathan, the energy savings were pretty significant for the project. We're obviously even more concerned about the economics of the whole deal. Can you tell me a bit more about how it all ended?
Yeah, thanks, Josh. In the end, it actually all worked out where the benefits outweighed the cost. And by benefits, we're talking about the valuation of the building. As Jared mentioned, we made a handful of changes and upgrades to the building to get us to net zero. It was these upgrades that were able to reduce our annual operating budget by 10% or $55,000 a year. This $55,000 a year savings translates into a valuation increase of just over $1 million, while the total cost of all these upgrades was just shy of 500,000. It's important to note here that before we make a decision in pursuing high performance sustainable buildings, our team needs to analyze and do a full life cycle analysis to determine if these objectives are mutually aligned with the financial success of the project, and in this case, it was.
So a question back to both of you. These are really interesting lessons that we can learn to take to some of our next projects. How are we going to look at sustainable development in the future in our next projects?
We're going to be implementing the strategies and the lessons we learned at Maple Meadows into actually two new self-storage facilities. The first one's going to be located on the island and is 200,000 square feet, and the other one is a 250,000 square foot self-storage facility with industrial on the ground floor located in the lower mainland. We haven't solved all aspects of the net zero equation, but we're establishing principles, and what we're doing is really understanding the process of how to reduce those emissions and align ourselves with federal and provincial targets. The larger the building, the more complex it is to design a net zero building. But our goal here at Nicola Wealth Real Estate is to continue to learn how we can build sustainable buildings and develop best in class assets throughout our portfolio.
And just to pick up on Nathan's point regarding the size of the project, I think it's important to hammer home the point that this is just one example. And each building, whether it's self-storage, whether it's office, whether it's multifamily, will be different in terms of the cost-benefit analysis. There's many factors to consider, but what we've learned through this process is that there are cost-effective ways to achieve and exceed our sustainability goals if we're willing to be creative and targeted in our approach. I mean, our goal is to adapt the lessons learned here and apply them across our portfolio. And we truly feel that we are just scratching the surface of where this can lead.
Nathan, Jared, thank you both for the insights about the project. Looking forward to completing this on schedule and on budget. Thanks to the viewers for watching. For more information, you can go to our website. You can follow us on LinkedIn and on other social media. Thanks a lot.